As we just saw, soluble compounds will dissolve in water. When reactions are carried out in water, we're going to put an AQ as the state of matter for those compounds that dissolve in water. For the ones who do not dissolve in water, we will designate those with an S. So how do we know if it's going to dissolve in water without actually doing the experiment? First, we use the solubility rules. And they're here. You will always have a copy of the solubility rules. Let's read through just a few to make sure you understand how to read these. The first one says that salts of ammonium and group 1 are always soluble. That means any compound that contains ammonium or a group 1 metal will always be soluble, which means if the reaction is carried out in water, we will designate it as AQ. Further, chlorates, nitrates, acetates are always soluble, so they'll also have the AQ designation. Let's look at the chlorides. All chlorides are soluble, except silver, mercury, and lead, which are insoluble. So that means that silver, mercury, and lead will not have the AQ designation. They will have solid behind them. That means they did not dissolve in water. If you scroll down, you see that sulfates are soluble, except, and the list is growing. And then somewhere around number 5, we see that it turns the other way. Phosphates and carbonates are insoluble, except for the ammonium and group 1, which we saw up in number 1. There are no contradictory statements in these rules. So let's look at the worksheet you're about to do. It's the solubility of solids in water. So we're going to go through and see if something is soluble. We'll look at the solubility rules. And in a minute, we will break down to the cation and anion that are soluble. And then we're going to see what we can substitute in for something that's aqueous. But first, let's determine soluble or not. Number 1, we have ammonium nitrate. Let's look at the solubility rules. Salts of ammonium are soluble. I can stop there. This is soluble. Okay. Let's skip down to number 4, lead chloride. What I'm doing here is I'm either looking for a category that's just lead, or I'm looking for the chlorides. So it's not in number 1, it's not in number 2, number 3. All chlorides are soluble except silver, mercury, and lead, which are insoluble. Therefore, our lead chloride is not soluble. Let's scroll down to number 6. This time, I've given you just the soluble cation and the soluble anion. Well, if I'm telling you they're soluble, then you can guarantee they're soluble. What would the formula be? Na is a +1, carbonate is a 2-. So we need 2 sodiums and 1 carbonate. Okay, so let's go up and see what we can complete. Number 1 we said was soluble. Therefore, it has a soluble cation and anion. Well, the cation is always written first. There it is. It's ammonium, and it is charged. It's a cation. And then the nitrate is written second. Okay. Now, in this category, what we're going to do is write the compound with an aqueous behind it, like we would see in an equation. But we're also going to write what that could be equal to, not yields, just equal to, synonymous with, and it's NH4 plus that's aqueous and NO3 minus that's aqueous. So if you come across something that says NH4NO3 aqueous, it's the same thing as saying NH4 aqueous and NO3 minus aqueous. So let's look at number 4. For number 4, I said it's not soluble, so it doesn't have a soluble cation, anion, and it doesn't have an aqueous substitution. Let's look at number 6. It is soluble. So if I see something that says Na2CO3 aqueous, I could also write it as Na plus aqueous plus CO3 minus aqueous. And I need 2 of these Na pluses because there are 2 over here on the left. It's not like balancing equations, but it absolutely has to do with conservation of matter. If you have 2 NAs, you have to have 2 NAs at the end.